This is a video on determining the convergence or divergence of a geometric series. The question states, determine if the series converges or diverges. And the series is a summation from n equals 0 to infinity of -1 to the n times 2 over 3 to the n plus 1. And with this series, we first try to identify what type of series this is. It may not look exactly like one, but this turns out to be a geometric series. And that's because we'll notice that all the constants are raised to the power of n or n plus 1, or just the constant 2 by itself. So what I'm going to do is a little bit of algebra to maneuver this series into one that really looks geometric. So let's start out by using the rule that says 3 to the n plus 1 is equal to 3 to the n times 3 to the 1. Next, what we can do is we can combine the -1 to the n and the 3 to the n. And I can rewrite this as a summation from 0 to infinity of -1/3 to the n times 2/3. Now, usually geometric series have constants in the front instead of to the right. So I'm going to switch this around and write this as a summation of 2/3 times -1/3 to the n. And now it really does look like a geometric series. So in particular, let's find out what c and r are. So c is a constant in front, which is 2/3, and r is the base of the exponent, and that's -1/3. So to find out if the series converges or diverges, we have a theorem that states that a geometric series converges if and only if the absolute value of r is less than 1. So the absolute value of r is the absolute value of -1/3, which is just a third, and that certainly is less than 1. So this does converge. Now we're not asked to find what it converges to, but just for fun, let's find it. We have a formula. If we know what r is, we know what c is, and we know that the absolute value of r is less than 1, then we can say that the summation converges to c over 1 minus r, or 2/3 over 1 minus -1/3, and I worked that out, and I got 1/2. So let's state the conclusion. I can conclude that the series converges, and it converges to 1/2. And I'm done with the problem.